Find the general solution of this initial value problem. So the homogeneous equation is z double prime plus z is equal to 0. And the auxiliary equation is r squared plus 1 is equal to 0. The roots, you take the 1 on the other side, so r squared equals -1. And when you take the square root of -1, you get plus minus I. And so this is the form a plus minus ib, where a is 0 and b is 1, because it's like plus minus 1i. And for complex roots, we know that this is the form of the solution. So the homogeneous solution is c1 e to the at cos b t plus c2 e to the at sine bt. And a is 0, b is 1, so e to the 0 is 1, so e term goes away, and cos bt is just cos t because b is 1, and then plus c2 sine t. So that's the homogeneous solution. And now if we look at the right hand side, we know that for exponential, the general form, let's go back to the basic forms that we studied. So it should be, let's see, is it 4.4? Yeah. So for I've written the form for a polynomial of degree n times an exponential. So here the polynomial is not there. We just have the exponential. So it's a general polynomial of degree n times exponential. So of course the polynomial term will be missing, and we'll only have the general exponential form. So the general exponential for this one be, so let's copy the template for YP. So let's see, YP. YP would be equal to, so since this is 2e negative 5x, so in general it would be like ke negative 5x, e negative 5x. And then after we write this, we look at the homogeneous solution and see if there are any terms which are similar. So none of these terms are similar. Neither c1 cos t nor c2 sin t is similar to k negative 5x. So therefore, we don't need to multiply by okay, actually, in this case, since it's all x, so this will not be t, but it would be x in this case. Okay, c1 cos x plus c2 sin x. And therefore, we don't need to multiply by any x or its powers to adjust the particular solution. It's already different. And now the next step is to substitute. So when you take the derivative of y, so in the original equation, we need two derivatives. Again, it's not y, it's z. Z, let's be ZP. Okay, so if you do, so the initial conditions are put in the end after you have found the general solution. So ZP prime ZP so ZP prime is, you take the derivative, that'd be negative 5k e to the negative 5x. And then when you take the second derivative, be double prime That would be 25k e to the negative 5x. Okay, and we substitute these in the given equation. To find ZP, we don't need the initial conditions. They will be needed at the end. So Z double prime is 25k e to the negative 5x. So let's just copy this. And Z is k negative 5x. Equals 2e negative 5x. So now this would be 26k e to the negative 5x. And we can divide out by e to the negative 5x. And so k would be 2 by 26. Is equal to 1 by 13. So now we have the particular solution, ZP equals 1 by 13 e to the negative 5x. Okay, so the general solution, now we'll write the general solution. YP, okay, to look at 4.5. Copy. So the general solution is YH plus YP, and YH we have, okay, so in this case it would be Z is equal to ZH plus ZP. And ZH is this one. Plus ZP is this one. Okay. So this is Z of X. So we can just write. Let's just write this without writing this intermediate thing. Okay, Z of X is this. So now the first condition is Z of 0 is equal to 0. Z of 0 is equal to 0. So Z of 0 be C1 cos 0 plus, oh, this was not C2x, but C2 sine x. I know how this was all along C2 sine x. C2 sine x, so similarly here it was C2 sine x. C2 sine x. Okay, so be C1 cos 0 plus C2 sine 0 minus e to the 0, and z of 0 was equal to 0. So cos 0 is 1, sine 0 is 0. So now this becomes, so cos 0 is 1, so this one goes away. Sine 0 is 0, so this whole term goes away. And e to the 0 is 1. Okay, so c1 is equal to negative 1 over 13. All right, so to find c2, we need to differentiate this because the second condition is the derivative of z at 0. So take the derivative of this. Okay, so let me copy that derivative template. Z prime x. So z prime x, you take the derivative of z to the x. So the derivative will be negative c1 sine. Okay, let's just copy this. Okay, so when you take the derivative of this, it would be negative c1 sine x. And the derivative of this term would be c2 cos x. And the derivative of e to the negative 5x is negative 5e to the negative 5x. So you'll pick a negative 5 here. So this would be negative 5 over 13. Okay, and now z prime 0 is equal to 0. That was the second condition. So z prime 0. C1 we know, we can substitute the value negative 1 over 13. C2 has to be found out, cos 0. This is sine 0. Minus 5 over 13, e to the 0. Equal to 0. Okay, so let's see, what does this give? This term goes away. So this one will be gone because sine 0 is 0. And okay, let's just do the step. So sine 0 is 0, so all this term is gone. Cos 0 is 1, so this part is gone. And E0 is also 1. So we get C2 is equal to 5 over 13. And now we have every constant. So therefore, where is Zx? Zx was here. C1 was negative 1 over 13. And C2 was 5 over 13. Okay, negative 1 over 13 cos plus 5 over 13 sine plus 1 over 13 e negative 5x. Okay, that finishes this section.